going to log me into Twitch. Stream Manager. I am live. Beautiful. If you're joining in, can I hear myself? Stream Manager. I am live. Beautiful. There we go. We're on. First things first, I'm going to share it out that we have to do that we are live. I think it's gonna start raining outside. It's a beautiful day. A beautiful day. I'm gonna go for a walk later. So let's write here. Going live on Twitch. Training large neural networks faster with TensorFlow's mixed precision. Come and say hi. Oh, no, I want Q, Twitch. I made a little shortcut. Save yourself lots of time by writing shortcuts in your keyboard. Going live on Twitch, training large neural networks faster with TensorFlow's mixed precision. Come and say hi. Boom. So get out of Twitter because that's an absolute time sink. Only use social media networks to share your work. And I'm going to share it on Discord. Let's go to the team. Yo team. Streaming live TensorFlow coding session on Twitch. No, I want Q Twitch. Discord doesn't do keyboard expansion. Twitch.tv/Mr. D Burke. Come and say hi. And we'll do a little wave emoji, you know. Beautiful. All right, where we at? Let's get a Colab notebook up. If you're joining, please say hi in the chat. Please tell me if you can hear me correctly. They're the two main things when joining a stream or when starting a stream. You never know when it's going to actually be live, and you also never know how the audio is going because I just turn it off. So I believe we're up to Food Vision Milestone Project. We're going to make sure this code runs end to end because that's how I develop my modules for courses. If you want to see everything on GitHub, let's go to the TensorFlow GitHub. TensorFlow Deep Learning. Do we have any? I think I have some discussions here. Personal tools question. You know how often I get, oh, it's gone. Well, this question, I believe, asked me what keyboard I use. So I need to edit. How do I delete this discussion? Edit. Delete. Oh, okay. Well, it doesn't matter. Oh, there we go. Delete discussion. Delete. Because it had nothing there. But this is a great way on GitHub. This is the Deep Learning TensorFlow course. This is what we're doing. We're building notebook number 7. So as you can see, the course is still a work in progress. However, there are 30 hours of videos already about this. But we're doing the final 4 modules here. Food Vision, this is what we're working on, notebook number 7. If you have any questions, you can ask them in the discussions. That's really helpful because then everyone else gets access to those discussions. But let's just keep that notebook or this GitHub open. And the projects, preparing for launch. I might have to rename this project. Edit. Post, pre and post launch tasks. This is what we're doing. Polishing notebook 07 ready for recording and learning. Let's go into this. We've got to start downloading some data because it's going to take a few minutes. So we'll connect. Please give us a Tesla T4. We need a T4 GPU. And you know, I was thinking about this stream setup. I might get my camera up here so that it's like on my face maybe. And this microphone seems like it's it's out of place as well because it's like sort of blocking the screen and it's sort of blocking the view, so it's not ideal. Oh, we have a K80. Little trick, factory reset runtime. Let's try again. Otherwise, we might not be able to do what we want to do. Initializing connected, please be K80. We're going to, what is this? 1 second, completed at 12:09. We're going to have to do what we can do before we get K80, because if we go import TensorFlow's TF, mixed precision won't work without Tesla T4 Plus. K80 and P100 don't work. Because we want from TensorFlow.keras, import mixed precision. We want mixed precision training, but if we use mixed precision dot global policy, oh my goodness, why are all of these, what did I just press? What shortcut did I just press to hide all of the cells? Mixed precision, if we try to set a global policy to mixed float 16, let's go TensorFlow mixed precision, one of my favorite documentations for now. Guide mixed precision. While this is running, I'm going to download some data, specifically the Food 101 data set. We'll cache that so that that runs. Now, how do I check what type of GPU that I have? NVIDIA SMI L, but here, mixed precision compatibility check, okay. Your GPU will run quickly with the D-type policy mixed float 16, as it has compute capability of at least 7.0. So this is in here. Now, if we check the set global policy method, can it just tell me what score my GPU is? Here we go. Sets the D-type, global D-type policy. This is what we want. Where's the source? Experimental. Overview. Chrome's crying at me. I think it's because it's downloading a whole bunch of stuff in the notebook tab. And is the stream going to catch up? The stream is caught up. Welcome back. So, TensorFlow, where's Keras? Python. I want to search, where's the source code for TF Keras mixed precision? Oh my goodness. My computer is having an absolute cry at me. What's taking up a lot of power here? Chrome and Streamlabs. We're just going to have to wait. And these blinds are really annoying. Open this one, and then close this. Open up that a little bit. Getting a little bit of air conditioning coming from the native sea breeze. The Sandgate Sharons have been very nice to me lately. Oh my goodness. New tabs galore. Copy and paste. No, we want... Is my copy and paste seriously not working? TF Keras Mixed Precision. Show me the GitHub for this. GitHub. Issues. Now, why can't I find this? Where is this, the source? Source. Set policy. No, I want to see source. TensorFlow, Python, Keras, there we go. Mixed precision, wonderful. This is what we're after. Set. There's no set. Policy maybe. Device compatibility check. Check test. Here's what we want to do. We want to just run the compatibility check. Supported device list. Details. For GPU in... Where's GPU? Config, get device details, G for G and GPUs. Log device. So I just want to run this. Device compatibility check test. So this is downloading the data that we need. Now, if we want to use mixed precision, we have to use a GPU with a certain score. So we're trying to look into this to see if we can just get our GPU score. Because if we go to policy, where's the set global policy? Oh, you can just do set policy. Now, where does it call? Where does it call to check my GPU? I just said that posh. Pre and posh launch tasks. Have we got data yet? No, almost do. Ashik, what's going on? Morning, my friend. How are you? Welcome to the stream. We've been diving into TensorFlow code. I think I'm getting too deep in the TensorFlow documentation, but we'll leave this there for the time being. Where's the blog? What's TensorFlow putting out lately? Transfer learning with audio. Oh, that's really cool. TensorFlow everywhere. Okay, we're almost finished. We've always got the data. There we go. We should have the data. We do. Now, if we tried to set the global policy, here we go. It doesn't work. See, your GPU may run slowly with mixed precision, mixed float 16, because it does not have compute compatibility of at least 7. So Tesla K80 is 3.7, not 7.0. So we need to see. I factory reset the runtime. Hopefully we don't need to re-download data, but we need to see if we can use a Tesla T4. There we go, baby. We've got a T4. And I'm going to run this later. But hopefully we don't have to re-download the data. We do. Sad face. But that's all right. We now have a T4. We can run with that for a while. So this is what we need to do. First and foremost is from head to tail. And then we can go through all of these other steps here. I'm going to put a note here. For mixed, Tesla T4 GPU, or at least a GPU with a compute score of 7.0 plus. Google Colab offers P100s, K80s, and T4s. However, the P100 and K80 aren't compatible with mixed precision training. How do I go here? NVIDIA GPU scores. NVIDIA CUDA GPUs. Ah, here we go. Compute capability. Quadro. Wonderful. So good news is my Titan RTX can do mixed precision training. So C for a list of GPUs and their compute capability scores. You need a GPU with 7.0 plus for mixed precision training. If you run the cell below and see a P100 or K80, try. I'm going to runtime, factory, reset, runtime, and retry to get a T4. Reset runtime. Note, this will remove any saved variables and data from your Colab instance. Okay, beautiful. Have we got the data yet? Almost, we're getting close. Extraction. So then we get the class names, explore the data. We need to make sure this runs from top to bottom. And then we can mixed precision training. Here's where's the main one. So this is what I'm saying. Your GPU will likely run quickly with D-type policy mixed float 16 as it has a compute capability of at least 7.0. Compute capability 7.5. Where does it say this? Compute capability. Now, where is the list of supported devices? How to calculate NVIDIA GPU compute capability. CUDA fact. FAQ. Frequently asked questions. Compute capability. The compute capability of a GPU determines its general specifications and available features. Ah. This is where it's telling us what it needs, or what it's capable of, depending on its compute capability. I want to find out where it calculates the compute capability. Oh, well. Have we got the data yet? Takes about 5 to 6 minutes. So this is one of the main things we're doing. Shaking basket. I'm trying to find out what GPU I'm using. You're right, shaking basket. I did get a T4. I've just reset my factory runtime on Google Colab. I'm using strictly Google Colab at the moment. So how long did this take? This took about 6 minutes. So yeah, that's the downloading data. Downloading data is what takes the longest. We're going to train a model faster than it took us to download data. Downloading and extracting data is taking a ridiculous amount of time. You are connected to a GPU but not utilizing the GPU. Oh, I'm going to utilize the GPU, don't you worry. So the first things first is to make sure all the code runs. That's what we're doing. Make sure code runs end to end. But we needed to get a Tesla T4 GPU to start off with. Tesla T4. So close. Now I wonder if we can explore where our data sets are stored. Sudo. Can't access root. Okay, that makes sense. So we can't access that where it's stored, but that's okay. Does this code work? It should work. Clam chowder. Delicioso. So I want to see what the image pre-processing looks like. Yes. And does this still work? Clam chowder. Yes. If we pre-process it. So the pre-processing functions that resizes the image, and that turns the images into TensorFlow float 32. Now we're going to pre-fetch our data. We figured out that this is probably the best combination. We map using parallel processing, then we shuffle, then we batch, then we pre-fetch. We don't shuffle the test data. And we don't need our TensorBoard callback because we've already got a function that does that. Hey, you got a Tesla T4, nice. Yeah, Tesla T4 has the higher compute capability. Shaking basket, you're completely correct. So Sheik, if you go to this website, nvidiadeveloper.com, or no, developer.nvidia.com, CUDA GPUs compute capability. So mixed precision training is you need a compute capability of over 7. So only these GPUs are available. So there's the T4 GPU. So this is what we're running. Tesla T4. Boom. So I'm going to copy that for you. Have a look at that. And now we've run our checkpoint and we're going to turn on mixed precision training. So this is what I was talking about before. If you see here, mixed precision compatibility check, okay. GPU will run likely with mixed float 16 as it has a compute capability of at least 7.0. Your GPU Tesla T4 compute capability 7.5. So there's our 7.5 here. NVIDIA T4 7.5. But before we're using a K80, which has 3.7. And if you have a P100, which is another GPU that Colab uses, that only has a 6.0. So we really need some of the later style GPUs to run mixed precision training. And this should output mixed float 16. Yeah, so if you don't have a GPU with 7.0 at least score, mixed precision training will basically either not work or it'll go slow, and maybe it won't even work in terms of its performance, so it won't be as accurate as a GPU with at least 7.0. So now let's build our neural network here. Wonderful, just an efficient net with a dense layer on top. And now the key thing we have to notice about mixed precision training is that our output layer uses the D-type TF float 32. That's an important thing. So now let's find out what check the D-type policy of layers. Now we want to check the layers in the base model. Now this is our base model, so this is efficient net. We want to make sure that they're all mixed float 16. Yes, that's beautiful. That's what we want. So mixed precision training is turned on now. So this is our base model, which is efficient net B0. And if we check all of the layers in our functional neural network, we have the input layer, which is float 32, which is fine because our data is in float 32 right now. Then we have efficient net B0, which is mixed float 16. Then we have a pooling layer, which is mixed float 16. Our dense layer is mixed float 16, beautiful. And our output layer, the softmax, is float 32, which is what we want. The output layer should be float 32 because it's more numerically stable than float 16. And so for our inference and output layers, we convert our tensors back into float 32. And I believe we'll be able to train it. So we're only going to do 3 epochs. This is the time that we got last time. So let's just save this. For feature extraction, time we got with prefetching data plus mixed precision training. So these scores should be very, very similar. Oh, what happened there? We want to copy this. So you ready? And we're validating on only 15% of the test data, so it goes a bit quicker. Let's run this. This should work. It's going to store the log files there. That's our TensorBoard callback. Yo, the best HC. Good to see you, my friend. Interesting project. Yes, it is a very interesting project. Thank you for that. Now, the first epoch, of course, is going to take the longest because the main issue we're going to have is our neural network, our code, is going to transfer data from the CPU to the GPU. You see how that time just started at something absolutely ridiculous, and now it's going really fast. So about 3 minutes is good. Oh, that's what we want. Do I still have my drawing? Or did it delete itself? No, it's gone. So we will wait for this to train. And then we can start to see We can evaluate our model. And then we can see if we load the weights from a checkpoint. What was the issue we had before? Last time when we loaded in a saved model, it wouldn't let us. Yeah, it turned off mixed precision. So that's the main issue as well. We want to save. We want to fix is we want to be able to save our model to file and then load it back in later and run it in mixed precision mode so that we can fine tune a lot faster. So there's a whole bunch of code that we need to clean up here. So we'll get the results, yes. And because we're saving from a checkpoint, loaded checkpoint model, load the weights. So that's what we can do. Yeah, great idea. TK, load and evaluate checkpoint weights. So new model, clone the model we created. This resets all weights. So cloned model will reset all the weights, yes. And then load checkpointed weights into cloned model and evaluate them. Should be so we go cloned model, compile, cloned model, same with same parameters as original model. And then we're going to evaluate cloned model with loaded weights. Should be same score as model. It's trained model. Cloned model. So we want to go results, cloned model with loaded weights. Beautiful. And we can go here. Go here. TK. Cloning the model preserves D-type policies of layers, but doesn't preserve weights. I think that should be good for loading the weights. Loaded checkpoint model, I don't think we need that. Now we can go here, TK, save the whole model to file. Gonna get rid of this, bring that up here. Starting to really clean up our notebook here because I want to at the end of this have all the code run from end to end, and I want to also have a saved model uploaded to Google Storage so that someone can just import the model. Yeah, there we go. Upload trained models to GS so student can download the trained version and use it. So that if someone just wanted to go through and try it out rather than having to train their own model, they can go to Google Storage. Yeah, there we go. Okay, 222 seconds, not too bad for the first epoch. Hasminator, what's going on, my friend? Or Ham, Hamzanated. Hamzanator. I said that name about 4 times wrong. I've said that wrong a fair few times since you've been joining as well. I remember you from previous streams. I think that AI has a great future in Latin America because its potential has not yet been exploited. What do you think? Well, I don't want to... Exploited is probably not the best word, but I agree. I think AI has a great potential all around the world. That's why I'm into it. It excites me, and I think it can be used for some really cool things. Maybe tidy up this code here. Oops. There we go. So about 1 more minute until we can evaluate our model. Results, feature extract. Model. Loaded checkpoint model. No, we don't want to do that. Don't need to do that. One of my favorite things is coming back through your code and then just canning the stuff that you don't need. Feature extract model with mixed precision. And saved dir, yes. However, I'm going to load this. Feature extract model with mixed precision. 07 efficient net B0 feature extract model with mixed precision. Yes, that can be the save name. Loaded saved model, and then what do we want to do? Loaded saved model, yes. This should be the same as results feature extract model. Is close. Assert. Yeah, so that's why we spent a fair bit of time saving our model, or we're going to, because training can be very time consuming, so we want to be able to continually load a saved model, and continue off where we left. My drive feature extract model with mixed precision. I'm actually going to get rid of with just to save one word in a saved path, because I'm pedantic like that. How's our model training going? Have we finished yet? We have. There we go. We got basically the same results as before. That's good. So that code is working. Tick. Now we'll run this. We should get around about just over 70.7. Shouldn't take too long here. Skimlet. Yep, that'll be on an upcoming live stream. So Shaking Basket is asking what Skimlet is about. Skimlet. So if we go RCT 200K, PubMed 200K dataset. So there's a paper here. We replicate this paper. So 17th of October 2017, so PubMed 200K RCT, a data set for sequential sentence classification in medical abstracts. So we look through the literature, or we build a model to go through PubMed literature. So hence literature, that's a part of lit, of SkimLit. And this model automatically classifies each sentence in an abstract, would help researchers read abstracts more efficiently. So skim abstracts, especially in fields where abstracts may be long, such as the medical field. So we replicate this paper to skim medical literature, hence SkimLit. So if we come to the PDF, this is the kind of spoilers you only get on stream. So if we have a look, the data, this is what the data looks like. Objective, methods, participants, and we're trying to classify, is this sentence an objective, and is this sentence a method? So if you imagine you go to PubMed, and you look at a paper, let's find a recent paper on nutrition. Parental nutrition. Oh, no, what do we want? We don't want parental nutrition. We just want nutrition. Promotion of physical activity during weight loss maintenance. How does this sound? How does this go? Okay, so this one has a formatted abstract. So it has objective, method, results, conclusions. However, this is actually a cool paper. I might read this later. I'm going to bookmark that. But what if it didn't? What if the abstract was just one big wall of text? And so that's what SkimLit does, is it goes through a medical abstract and classifies whether a sentence is a conclusion, results, method, or objective. That way you can quickly skim through the literature. Imagine if you had to read 100 papers in a day. Wouldn't it be cool if there was a Chrome extension here that you could just go SkimLit, and it would break the abstract from one wall of text into these 4 easy to read paragraphs. And so if we look at the paper, I think where do they say? Do they say what model they use here? No, their model is actually in another paper, which is in Neural Networks for Joint Sentence Classification. I believe it's in this paper. Existing models on artificial neural networks, however, they don't incorporate the context. So we build a multimodal model using the functional API to replicate this model. Here we go. So you need character embeddings, you need token embeddings, we need to concatenate them, we concatenate them, put them forward into a by LSTM and then a feed forward layer. So we basically recreate this architecture using TensorFlow. Okay, our model did very well. That's what we want. Now let's try the clone model method. So that's just a little spoiler alert of what's to come. I'll be streaming that as well. I've already got all the code ready. I just need to go back through and make sure it all works, just like we're doing here. Cloned model. Now, the results should be the same as before. So we can go here, import numpy as np, assert np.isClose. IsClose. We want results, feature extract model, results cloned model with loaded weights. These should be very close. And cloning the model preserves the D-type policies of layers, but doesn't preserve weights. That's what we should want as well. We don't need that. Does this work? Assert. Maybe this is not a list. Copy that. Should be true, true. How do you check if a whole array is true? Truth value of an array with more than one element. There we go. Check if all elements in array are close. Dot all. Beautiful. So loaded checkpoint weights should return very similar results to preloaded. No, to checkpoint weights prior to saving. Okay, beautiful. All mixed float 16, wonderful. Now, here's another test, is we want to be able to save the directory or save the whole model to this path. And then save the model. Model checkpoints. We want to save the checkpoints there. This is saving the entire model. So now this should, if we load the save model, this is what we had issues with before. There's going to be a whole bunch of warnings output here, but we're going to can all of this. Can I do this, suppress the warnings? TF Keras load model. What parameters does this take? File path, custom objects, compile, true, options. What's options? Load options. No, don't want that. That's all right. I can just can the output there. Don't worry about that. And now we want to check the loaded save model. We want to check all of the layers. Let's go here. Does loading a saved model retain all of the underlying layers D-type policy? We want them to be mixed float 16. Mixed float 16, yes, that's what we want. D-type policy. Now, I believe I got confused before because the D-type is float 32, but the policy is mixed float 16. So that's confusing. I'm going to put a note here, TK. This is for my own good and for people who are coming to this notebook at a later date. Note. Layer.dtype and layer.dtype policy are two different things. For example, a layers.dtype attribute may return float 32, but a layers.dtype policy attribute may return mixed float 16. And then TK, why is this so? All right, now we've saved the whole model, we've loaded the whole model. Now let's get loaded saved model. Let's get the results. So assert dot all results variables. Loaded model should equal or at least be very close to the loaded model's results to the model's results prior to saving. That makes sense, right? Wonderful. Should be very close. There's our loaded saved model, 70.64. We can go here. Assertion error. Results feature extract model. I need to go to the bathroom. I'll be back in a second. This is exciting, team. We're making some great progress. So loaded model for fine tuning. Don't compile on load. Why did we do that? Replace the above with Google Cloud Storage link. How about we do that right now? Since it's working, let's download our saved model or upload to Google Storage. So drive, this is where it's written, saved here. And how about I just go model.save. Save, I'm going to save it just locally. Should come up over here. 07 efficient net feature extract model mixed precision. And now I want to upload model, save model to GS so we can load it later. So I need to authorize Google Colab. I have a notebook with code like that. CS329S, here we go. Just going to do this over here so that it doesn't show up on the stream, you know. Just in case. So, authenticate Google Colab. Yes. Okay. Authenticate Colab and gcloud and net. So I'm going to save this to my code snippets notebook or code snippets documentation. So there's full stack deep learning, course that I'm currently enrolled in. And where's my code snippets? Code snippets. If help, need look below. New. Authorize Google Colab to have access to, no, not GSUtil, gcloud. Description, upload files from Google Colab to Google Storage. Authorize Google Colab to gcloud. Give Google Colab access to Google Cloud. So a whole bunch of different. Now what do I want? gcloud? Yes, it is. It's Colab. And the code can be install gcloud. Requires setting project, etc. Okay. Beautiful. So now when I need to use that bit of code again, I can come back to Notion and use it there. So I'm going to run this just over here. Yo, Lazy is playing. How you doing, man? Mr. Robot. Enter the verification code. Might just turn the stream completely off for a second. Now you can look at me. I'm just while I'm, oh no. Maybe I just go here. That'll do. Enter the verification code. Load it. Sign in. Allow. Copy. Enter your verification code. Enter. This is God tier live streaming right here. Can that. And oh, my bio on Twitch, is that what you mean? I'm pretty new to Twitch, so that's why it's not filled out or anything. I'm just experimenting. Create new configuration. No, my bio is I'm a machine learning engineer, and I'm creating materials for a TensorFlow course that I'm working on at the moment. Which in TensorFlow is, if you're not familiar with that, is okay. Beautiful. I think I've done what I need to do in that little part. Sorry, I'm just running some code at the moment. I can give you my bio if you like. Actually, I've got an idea. You can read about me on mrdburke.com/. Do I have an about page? I'm pretty sure it's called about. Oh no, www.mrdburke.com/about. But I make YouTube videos about coding and health. Here you go. I'm the internet's most shredded machine learning engineer with a mohawk. You got to own your niche, you know? So let me just get out of that. Okay. No, I don't want to get out of that. Come on, Shift T. How do I upload? Did my model work? It did. Beautiful. Now I'm going to upload something to Google Cloud Storage. So now I just ran this and entered all the code that I needed to run. So now I'm going to store my saved model on Google Cloud. So that way we can reload it back into this notebook without having to retrain it again. Should have really done this ages ago, but this will do. GSUtil, copy, recursive. Then I need to copy this path. And I'm going to copy it into Google Storage. So let me go console, Google Cloud Console. I love Google Cloud. This is not a... Oh, I'm not going to be charged very much for this month. That's excellent. So I need to go into my storage bucket here. Google Cloud, if you're watching this, please send me credits so that I can work on some projects later and not be charged exponential amounts for using your services. Copy the path to the clipboard. Done. Beautiful. So there's a pre-trained model that we saved before for number 6. I'm going to do the same and upload this model to Google Storage. Where did that go? Does that copy the whole path? No, it doesn't. GS TF course. Actually, does it save it to there where I want it to? TF course. Do I have the same path there? But lazy, thank you for the question. I need to figure out how to update my Twitch stuff. I will do that over the next couple of days. Where is my other... my Discord is... It's 0 to mastery. However, that's for students that I teach. So I don't have a public Discord. Is this going to work? I suppose it won't really matter if it doesn't, because I can just erase things. No, I think it needs the path. Let's just try it. Yeah, why not? So if this works, it should have been really quick. Did it work? Food Vision. Refresh. Notice that there's no 07 here. There we go. 07, that's what we want. Now, ready? I'm going to make this public to everyone. Oh, does it need to be a zip file? It does. I see. We need to zip it up. Okay. So, what's a zip file? So I need to zip this folder. Zip. How to zip on command line. How to zip a folder using terminal command line. Zip R, my new file, folder to zip. Okay, that's pretty straightforward. Zip recursively. I want to zip this .zip, and then I want to zip that folder. Does that make sense? We'll find out. Do we have a zip folder? We do. Wonderful. So now let's upload the zip version. Wonderful. Now we should have the zip version up here. And we do. Okay, now I can make this public. Oh, but it's only 16 megabytes. That might be public. Save. We'll see if it works, right? That's what we're going to do. Copy URL. Do we have... We don't have unzipped data. That's all right. So let's come down to where we were before. Here. So loaded GS model equals TF Keras. Oh no, we need to download the saved model from Google Storage. We can do that using wget. So I'm going to delete the version of it here. I'm going to delete the saved one we already just did. So I'm going to delete that. Yes. Unzip the saved model downloaded from Google Storage. So is that going to download? It does very quickly. Wonderful. So you can download that one yourself. We can work with the same model if you really wanted to. Mixed precision zip. Now to unzip, I've got a folder. Can I just go unzip? Unzip. Where to unzip it to? Loaded GS model. Or downloaded GS model. Unzip. File.zip. List. D. Oh, I need D. Unzip. Did that work? No. Did that work? Caution, not extracting. D ignored. Oh, because that doesn't exist? You know what? Just going into how to unzip on command line. Now, why don't I just go make dir downloaded. Is that going to work? What's D? Usage. Z. File. Oh, it did work. Model. Oh, that's what stuffed me up. D. Where's D? Does that work? D. Ignored. I've got a function for this, but I'd like to try it on the command line. D flag for destination. Australian. Yeah. I want it to go to this folder. Oh. Copy path. Now, load and evaluate downloaded GS model. Loaded GS model. Thank you, Shaking Basket. Equals TF Keras models load model. Loaded GS model dot summary. Here we go. Fish on. Oh, all the parameters are trainable once they get loaded in. So loaded GS, so results loaded GS model equals results You can look me up on LinkedIn as well if you want. Lazy is playing. Just under Daniel Burke. Yes, it's working. That is what we want. Fichon. Layer.dtype. Layer.dtype policy. Now we need to make sure that make sure loaded model is using mixed precision dtype policy. Mixed float 16. Boom. That's what we want. That's what we want. Our Google storage model is working as expected. So let's check our layers in the model. No, we need loaded GS. No. My goodness. Yes, that's what we want. Our loaded model is still using mixed float 16. We've got a big question here, some advice from Duroxigar. Need a little advice. I'm currently building a site to predict who would win in an esports match. I was able to find a tutorial that covered building a neural network. However, I'm using an MLP regressor because I need to predict who would win in a match. I believe I have the model trained correctly because I'm not getting any errors and my R2 squared is about 0.97. That's a good R squared. My next step is to figure out how to plot it. But my question is more, how can I use this to predict who would win in a given match? So, Duroxigar, I would say to predict who's going to win in a given match, you need to get the match you want to predict on. You need to get the information from that match you want to predict on into the same form as your model was trained on, and then use that as your model's inputs to like a predict function or something like that. So if you're using an MLP regressor, maybe with scikit-learn, neural network MLP regressor. So it has a predict function. So see here, if you fit it on certain training data, you need to get the data, in other words, the test data, the match you want to predict on. You need to get that data in the same format as your training data, and then run your MLP regressor to predict on that. And then you should have some sort of result from there. But we are in a good place here. Loaded saved model or loaded GS model. I don't need that actually. Now, are we still on mixed precision global policy? Yes, we are. I'm going to 10 times lower the learning rate. Loaded GS model. But yeah, prediction is the same, almost the same as training, as long as your prediction inputs are the same as what your training inputs are or were. Loaded GS model compile, lower the learning rate by 10% or 10x because we want to fine tune. Loaded GS model. We are still using mixed float 16. We're trying to beat the deep food paper here, by the way, with what our model is doing. So if we look what results they got on Food 101, this is a really good way to practice your deep learning skills, is to just find a paper and beat whatever result they got. So 77.4, now this is an older paper. Yes, I know there are better models than this in papers with code, but just as a sort of a benchmark for yourself to just try something out, you need to build momentum with these things. 77.4, that's what we're going for with this fine tuning. So create some callbacks, early stopping, patience 3, I think that'll be enough. Learning rate, reduce on plateau. Loaded saved model, we don't want that. Loaded GS model. GS is for Google storage, by the way. Loaded GS model. Compile. Do we need to compile? We just compiled back up there. Compile. Yes, we did. We've already compiled. Sparse categorical. Why did I recompile up here? I don't think I need that. I'll copy this. We might need that comment. Yep, we've already got that. Model compiled. Loaded GS model.summary. Beautiful. We have a whole bunch of trainable parameters. What are the non-trainable parameters? Oh, I think they will be the batch normalization layers. That's fine. That's fine. That's fine. Loaded GS model dot non-trainable weights. Yeah. Batch norm. Batch norm, that's what we want. And then what's the len? So for every batch normalization layer, they won't be trainable. 101. That's okay. Done. Loaded GS model. We've checked this about 100 times. Okay, I'm going to remove these because we don't need to check. So this is going to be loaded GS model. And fine tune. Have we got all the stuff we need? Model checkpoint. EfficientNet B0, 101 classes, all data. Fine tuning. Yes, we do. Training logs. I might do a little B there. Train data, yes. Test data. Now, ideally, we want to get the same testing results as what we got before. So, results from fine-tuning with prefetched data and mixed precision. So, a big shout out to Ashik, by the way, who went through this notebook on GitHub and told me where all the errors were. So this is, I haven't updated this one, but this is where we were before this stream. So Ashik ran through this and told me where all the errors were, which there were a lot. So that's what I've been going back through and fixing, by the way. So Ashik, thank you very much for that. I really appreciate that. And so I think we want loaded GS model. Results loaded GS model equals loaded GS model dot evaluate. Results loaded GS model fine tuned. That's what we want. Fine tuned. And the previous results that we got, previous fine tuning results with prefetched data and mixed precision. Very hacky, but that is fine with me. Okay, you ready? We're going to run this. Probably take about 15 minutes or so. 3, 2, 1, as long as there's no errors. Saving training logs. Epoch 1 of 100. That is fine because we have an early stopping callback. We also have model checkpoints. And we also have reduced learning rate. So if our model gets stuck during fine tuning, we'll try to lower the learning rate. Boom, we are on. Fish on. Model starting to train. Should be very fast compared to that. Oh, no, sorry, it should be this, about this. 305 seconds. Whereas previously, look at this time. I had 1400 seconds when I didn't use mixed precision. Didn't use mixed precision and didn't use fast data loaders, and I got 1400 seconds. So I need to save that. So by the end of this little fine-tuning session here, we want to have better results than 77.4 top 1% accuracy. So we'll wait for that to run. Okay. Where are we gone? Whoa, we have a few chat. Sorry, chat, I've been distracted by code. Dan, did you see the new switch transformer? I believe I did. Switch transformer. Is that a Google, right? French Toast Mafia. Google released a blog post on it. The switch transformer. Here we go. Switch transformer, mixture of experts. So that means you combine a bunch of relatively good models and the combination should be better than the individuals. That's how I understand it. The result is a sparsely activated model with outrageous numbers of parameters. I love that. Outrageous numbers of parameters. But a constant computational cost. That's what we want. However, despite several notable successes of mixture of experts, widespread adoption has been hindered by complexity, communication costs, and training instability. We address these with the switch transformer. We simplify the MOE routing algorithm and design intuitive, improved models and reduce communication and computational costs. Our proposed training techniques help wrangle the instabilities, and we show large, sparse models may be trained for the first time with lower precision. bfloat 16! That's what we're using. We're using mixfloat 16. But bfloat 16 is for TPUs. Yes, look at what we're doing. We're doing similar stuff to this. Of course, we don't have as access to as much compute, but we're using the same techniques. We design models based off the T5 base and T5 large and obtain 7 times increases in pre-training speed with the same computational resources. Wow. That's very cool. I'm going to read that paper. Save that to ML. Thank you for that, French Toast Mafia. I'm working on a face Hamzinator. Let's check out training actually. We'll let the training run while I check out the chat. I'm working on a face recognition system. I'm trying to make aliveness. Should I just put this over here so you can see if you're watching this later? I'm trying to make a liveness detection model to detect whether there's a genuine person in front of the camera, not just a picture of a person. I personally don't have any experience doing that, but I would look up adversarial image detection. So this is what you want. Something on adversarial detection or adversarial face detection. I'd look up something like that. And I think Pi image search just put up a new blog post. Where's the blog? On adversarial detection. Yeah, defending against adversarial image attacks. So, holy crap, ads galore. There are enormous consequences to deploying undefended models into the wild. By the way, I'm going to also save this one. I want to check this out myself. That can go under computer vision. So I'll link this to you, Hamzinator. You want to check out adversarial attacks and see what you can do for that. Adversarial image defense is no joke. Yada, yada, yada. Yeah, that's what you want to look up. I don't particularly have any experience with that myself, but this is where I would look into. What else do we have? Jiroxigar says, all right, so I have my model. We'll go back to the training. So I have my model, just grab the given match and take the stats, the match position, yeah, and plug it in. Kind of makes me question if I actually did train my model though. I've already called the predict once before. So Jiroxigar, like the training that you would probably do, I'm not familiar with the exact problem that you're trying to work on, but the training that you would probably do is, say you're just trying to predict esports winners. You would have, say, for example, a whole bunch of winners and losers, a whole bunch of previous matches, and then different parameters for each of those matches, such as someone's skill level, how long they've been playing, their team, etc., and you're trying to predict win-loss. So you would train on that type of data, and then for the future matches, you would try to use your training data, the patterns that your model has learned in the training data, to predict who's going to win in a future match. So you would have to input to the predict function data in the same format that your model was trained on. ProSimp says, hi, what's going on, my friend? French Toast Mafia, yes, it is Google. Beautiful. Great paper. Thank you for that. Now, how do I... Oh, I want to show you something. I have a Daniel Burke. No, can I just type it in here? Q archive. If you go to YouTube, Daniel Burke archive. Boom. I have a YouTube channel for watching past streams. If you want to see past streams, see here. Alex, French Toast Mafia is Alex, so I don't have to say French Toast. Thank you for that. I'm going to subscribe to myself. So go and check out Daniel Burke Archive for past streams. How do I add this to my Twitch profile? Should we edit my Twitch profile together? Twitch.tv/Mr. D Burke. Can I edit this live? We're waiting for our model to train, by the way. TV/Mr. D Burke. I need to mute this. So edit. No, I want to edit panels. How do I just add a link to my profile? Channel. There we go. I'm on it. Like if a Spartan warrior. Add social links. Here we go. Username, display name, bio. Add. Pass streams on YouTube. Watch. Read stuff on my website. Oh, this is cool. Where should this link go? https mrdburke.com. Add social link. What else should I add? See my main YouTube channel. YouTube, I don't even know my channel link. Your channel.
At the top, maybe a car, a self-driving.
Jesus. I need to turn off autoplay. Add. See my main YouTube channel. Read stuff on my website. Can I reorder these? And maybe follow me on Twitter. https www.twitter.com Mr. D Burke. Boom. Okay, what does that look like on my profile? Muted. There we go. There's my links. Is that all I need? I want the two YouTube to be together. Can I reorder these? Oh, there's my website. Holla. I'm going to reorder this. See my main YouTube channel. Read stuff on my website. Oh, that was actually very straightforward. Okay, that's enough profile editing. Let's go back to the chat. Yeah, shaking basket. That's a great idea. I do need to download the Twitch chat and put it in there. Let me just put this over here so everyone can see the chat. How do I make this bigger? There we go. It's like Inception with the chat. Yeah, Sheik, how can we get fancy banners for our boy? Jiroxigar, it sounds like what you're doing is like along the right paths. So that the only data that you have is kills, deaths, win, losses, win percent, and KDA. So what are you trying to predict? Like you're trying to predict whether who's going to win? Like as in, if you got two players together and you're trying to predict whether player A will beat player B. That sounds like you could definitely do that with their past data. It depends on It depends on where, if you want to predict that sort of stuff, it of course what data set you use. I'm not aware of any like esports data sets, but you could do web scraping of some sort for esports websites. I'm not familiar with really any of those, but or you could just that's pretty manual. Like you can find out, does anyone do like a report on esports results? Like I'd get really like niche. So like pick one video game, pick like make sure it's like one-on-one players or something like that, and then like the end result is win or loss. And then if you can find that data set, start with like just 100 matches or something like that, and then see if you can build a model to predict on those 100 matches. So split it up into a train, validation, and test set. Train on 70% of the samples, and then try to predict on 30% of the samples based on what your model's learned on what they trained on. However, if you want an example, I'd look up this. Predicting, this is not video games, but predicting customer churn with machine learning. So customer churn prediction using machine learning. Now, it is not predicting who's going to win a video game, but it is predicting will they churn or won't they churn, which you could turn. And what churn means is, say you had an online web application and you want to predict your customer's going to sign up, and churn means will they leave the platform. So you could flip the example here with churn and not churn to win-loss, but it's still a binary prediction. That's what you're probably going to start with. This is just a long-winded article. Where is the code? Maybe you want to read all this background information to it, but I just want to absolutely no code. Here we go. Churn prediction with machine learning. Customer churn. What is customer churn? Wonderful. Jupyter Notebook. This may help. May help. I'll link this. You can have a look at that. Oh, well, that's great. Yeah, generate random numbers within reason, and then see if you can what it's like to train a model on that. Oh, we're getting close over here. Oh, look at that, validation accuracy. But yeah, I would say, Jiroxigar, check it out. Look up something like, predicting customer churn. Because I would say the features, although it's not the same problem, but it's still taking in a number of parameters about a particular person and then predicting what action they will take, which is similar to what you want, which is predicting who's going to win out of a certain esports game based on a number of parameters. So it's what action will someone take, and in your case, win or lose, versus churn or not churn. Spartan Warrior Learn to Code is the best buy. I really like that. Okay. So what do we have to do after this? Let's go back to this. I need to, have I saved that? Yes, save that, switch transformer, unzip on the command line. Yes, let's clear out some tabs, hey? CUDA, did I save this link? I really hope I should. I did. Go back up. Yes. We need to go here. Look how many TKs I have here. But this is all right. TK, check GPU. This is all right because this notebook is gonna be, the code is gonna be finished on this notebook today. However, the words I'm going to fill out tomorrow. And then this notebook will run end to end beautifully with explanations in tow. So that is what it looks like. We can get rid of this. Model.save. Loaded GS model. .save. I want to save this to my drive. I want to go 07 efficient net B0 fine-tuned 101 classes mixed precision. Wonderful. Fine-tuned, yes, we will save that. Results fine-tuned model equals loaded GS model. Maybe we'll change the names of that, but that's all right for now. Loaded GS model, and then I'm going to add some text here because I want a TK. Upload fine-tuned model to GS and load it in to prevent having to re-fine-tune. Is that a word? Re-fine-tune? Re-fine-tune another model. Wonderful. Update text. We did beat it without data augmentation. Yes, that's true. Visualize the training on TensorBoard. Oh, we can do that next. Yeah. We're going to change this to Google Storage because not everyone has access to Google Drive. TK change to Google Storage. Exercises. Wonderful. TK read up on the documentation for TensorFlow mixed precision training. Improving TensorFlow data loading performance page. This is going to be an outstanding notebook once it is finished. Upload fine-tune model. How's the fine-tuning going? How much do we have left? Is it already finished? Here we go. It's done. Accuracy. Loaded fine-tuning. That's going to run. I've been working myself with the fitness videos which you posted during the Corona days around August. Best workouts. Feel a better me, especially the prisoner one. Oh, thank you, Ashik. I'm so glad you enjoyed that. I should post more workout videos, shouldn't I? More workout and cooking videos. How about I try that? So are we going to beat the deep food paper? Are we going to beat the deep food paper? Yes, we do. Save model to drive, but I also want to save model locally. Loaded gs model.save. I'm going to save it here, and then I'm going to upload it to Google Storage. So I'm going to run this. I need to go to the bathroom again. I'll be back in a second. Be right back. Bathroom break. Oops. Beautiful. Model is saved locally. We need to evaluate this and then upload that to Google Storage. I'm going to go get a quick drink and I'll be back in another second. All right. Milk. I love milk. Milk and coffee. Let's turn this into some code. So we've got our model saved to Drive, but really we want this one. We can upload this one saved locally to Google Storage. So is that here, fine-tuned? Yes, it is. Did I spell EfficientNet correctly? Fine-tune, 101 classes. Yes, this will do. So let's upload this to Google Storage. That way I can, so upload saved model to Google Storage to download and reuse later. So we go GS. No, what do we need to do? We need to zip it first. So zip saved model file. So zip. Do we have any tags? Stuff it. We'll just try it out. We need to learn these things. Zip. File to zip. That's the destination. And I believe the target is this. Well, we'll find out in a minute, won't we? Zip. Oh, did I need the R flag? For recursive? Why don't we try R? What does R mean? Recursive? Zip R. What is R in zip command? Who knows what R is in the zip command? Zip command. Zip parameters. Where's R? No, don't want that. Okay, that makes sense. Okay, now we're going to upload it to Google Storage, gsutil. gsutil recursive, and we want to go gs ztm tf course food vision. Run. This shouldn't take too long. Command R. Oh no, CP. CPR. Did you pick up on that? Wonderful. Now let's check to see if this is available. 07 fine-tuned. Yes, it is. Let's make this public. Public. Copy URL. Save to Google Storage. That's what we want. Download and evaluate fine-tuned model from Google Storage. wget, boom. Unzip fine-tuned model. Want to go unzip. We're going to have two of them, aren't we? I'm going to delete both of these. Then download a fresh one. copy path, unzip to the destination, which can just be 07. No, we need to make dir downloaded fine-tuned GS model. Downloaded fine-tuned GS. What happened? File name not matched. Okay, we need the D flag for... Wonderful. Copy path. Load in fine-tuned model from Google. Is my head in the way? From Google storage and evaluate. Loaded fine-tuned GS model equals TF Keras models load model path to that. Loaded fine-tuned model summary. Beautiful. Results loaded. Fine-tuned GS model equals loaded fine-tuned I'm going to need to fix that variable. Results downloaded. Run that. Oh, thank you, Shaking Basket. Hold on a minute here. What just happened? Oh, we got the feature extract model into there. That's why it didn't work. Let's just be careful of remove R. That's what I should try right now. This is disable warnings. Two, set level warning. Let's try that. Before. So this is before. And what was it? Well, I've already got TensorFlow, but I'll just write the full thing in here anyway. TensorFlow, hide warnings as TF, get logger, set level warning. You reckon info or warning? We'll try warning, or we'll try info. Nah, we'll try warning. Oh. Still doesn't work. TF, get logger, set level. TensorFlow hide warnings. So like this. Info. Then if I try to load model, where's my docstring collab? Set level error. I'll read through this later. Where is... Okay, get out pocket. Ah, error. I get it. Yeah, error will do above. Thank you, Z Paranoics, and thank you, Shaking Basket. Error and above. Shaking Basket, where are, Z Paranoics, where are you getting that level? Level for humans. Is that it's in the doc string here? It's not giving me a doc string there. I can't find the set level. Okay, that's going to... Oh! It doesn't hide the warnings. That's all right. Yeah, the TensorFlow documentation is garbage for that function. I just set it to error. V, this is 2017, working through TensorFlow 2.0 plus. Okay. Two point oh update. Okay, here we go. Okay, maybe I'll try this. Error. Set an OS environment. Wow. I guess we're stuck with it. Maybe you have to do this when you first import TensorFlow. Maybe. Because otherwise it's just using a cache version. That's what I'm thinking it might be. Like it's cached TensorFlow in my runtime, so it's not actually re-importing TensorFlow each time you run this. That's what I think it might be. Let's run this to see if our model works from Google Storage. I think it might be because my version of TensorFlow is cached. That's why it's not working. But if you do this at the top, it might work. Error. I'll be very surprised if it works with single strings and not double strings. Boom, that is working. That is what we want. Loaded, fine-tuned model from Google Storage is working. We need to finish that text. View the training results on TensorBoard. So I want to, yeah. I don't need this. We've already loaded it. I'm going to put this up here. TensorBoard uploader. What do my logs look like over here? So I need to authorize this. So now we can check out my experiment on TensorBoard. Oh yeah. Now we want it on, let's do it just the validation data. Oh, so the epoch, actually, let's just check out. So the fine tuning, it's clearly overfitting because validation loss is increasing. So that's something for an extension, is validation data or validation loss increasing. Whereas training loss is just going bonkers. Okay, beautiful. Um, where's the delete function? need the tag. All right. We've done what we needed to do, is make sure code runs end to end. Wonderful. Now let's go back through and figure out where we can clean up different parts. We'll try set level error with one string. If that works, I'm done. No, it doesn't work. Hide warnings, we may be able to hide them up there. I think we already have that. Download and evaluate from Google Storage. Yes, that is correct. Get rid of that. Get rid of that. Get rid of that. Get rid of that, because we have it in Google Storage. Mix precision. So maybe we go back through it again and just make sure it runs. Upload model available for GS, yes. Replace that. So what was the next step we said we wanted to do? Clean up data loading, yes. Clean up headings, yes. Remove model loading code. Clean model loading code. Yes. Use mixed precision training for fine tuning. Yes, that works. Upload trained models to GS so a student can download the trained version and use it. Shaking basket, great idea. Yeah, I think it's cached at the moment, so we're going to get warnings. That's all right. We'll keep cleaning up the code. Mixed precision. Helper functions we want. Download data using TensorFlow datasets. Yes. So the data loaders, the downloading data all works. That's great. What does an image tensor look like? Yes, plot one. So I want someone to be able to run this notebook end to end for themselves if I uploaded it to Google Storage. GitHub. I'm trying to figure out where the breaking points are going to be. Don't want that. Save model locally. Stay there. Come on, microphone, work with me. Note, Google Colab storage is ephemeral and your model will delete when the Colab session expires. Where could I put this microphone? That's better. This is what I want to think about this setup, because this is good for recording videos, but when I'm live streaming, like the angle is here, the microphone's in the way of the camera. Is it better to have maybe a camera up here or something coming down and a microphone coming over here? I don't know. And this microphone is not long enough or not heavy enough to keep the stand weighed down. Oh my goodness. Stay there. Can you hear me if I just sit the microphone here? Is that okay? That sounds all right. If I just have the microphone sitting there, let me know in the chat. So model save, is that gonna... No, we don't need this. Don't need this. Don't need this. Don't need this. Loaded models saved. Yes, that should work. That should work as well. If someone downloads now, I don't think we actually need that. Trying to make this as simple as possible, you know? Okay. Can that. Thank you, Shaking Basket. So where are the other bottlenecks in here? All right, I think we're on the path. You know what I'm going to do now? Rerun it end to end. Make sure it works. Ashik, you want to run this with me? You still watching the stream, brother? I'm going to save this in GitHub. Sign in to GitHub to continue. Okay, let's do this. I just want to go, how do I go G85 only? Sign into GitHub, and then we can just hide that. So my email address is that, and then 1password7. GitHub, copy. I'm just signing into GitHub, that's why I have to turn my screen off. All right, I believe we're back on. Boom. Okay. So TensorFlow Deep Learning. I could just leave that there, couldn't I? TensorFlow Deep Learning. Clean up a bunch of code. Notebook should run end to end. TensorFlow deep learning. Shivans, what's going on? I was talking to a CEO of an AI company related to medical software as a service, but they want PhD and master's level experience. Can I still gain that knowledge self-taught? Yes, you can if you just start the job before you have it. Check out this article. So this notebook should run end to end in So if you guys want to try this out, nope, this should work without changing any paths. So if you try that out, it should run end to end without any paths. And you know what? I'm going to try it myself. You will need a Tesla T4 though. So I'm going to reset my runtime. Let's all do this together. This can be the way to finish out this stream. How about we do that? How long have we been going for? 2.5 hours. So look at that. Reset factory runtime. Now check GPU. We need a Tesla T4. This will only work with the Tesla T4. Try to run the notebook I just linked. Boom, we have a Tesla T4. I'm going to run this together. Helper functions. Just try and run this head to tail and see what happens. So the getting the data part is going to take the longest. Oh, big stretch. Okay, what can we look up? Who's got some cool stuff that we can look up while the data's loading? What should I look up? Fast AI. Have they got any new blog posts? No, they don't. Let's go to full stack deep learning. Full stack deep learning. Or actually, what's NVIDIA working on at the moment? NVIDIA. I'm pretty sure they have a conference going on at the moment. Oh no, GTC 2021. The ultimate play. RTX 3060. RTX 30 laptops. Game on. Jan 2021. Omniverse. What is this? Design visualization. Okay, let's go back to full stack deep learning. What do they have here? Where are we up to? Here we go. Dream versus reality for ML practitioners. This is very good, by the way. This is what I'm reading. Fullstackdeeplearning.com, Spring 21, Lecture 6. Check Ashik's GitHub. You got a link, Ashik? Ashik Shafin, GitHub. Hey. Ash Blogs, is this you? is not you, is it? Send me the link to your GitHub. And somehow we build an optimal machine learning prediction system available as a scalable API or edge deployment. That deployment then generates more data for us that can be used to improve our system. The reality is you will need to aggregate, pre-process, clean, label, and version the data, write and debug model code, provision compute, run many experiments and review the results, discover that you did something wrong or maybe try a different architecture, write more code, deploy the model when you are happy, monitor the predictions that the model makes on production data so that you can gather some good examples and feed them back into the data flywheel loop. Operation Vacation. Their dream is to build a system, so Tesla self-driving system, that goes from the data gathered through their training, evaluation, and inference processes and gets deployed on the cars. As people drive, more data will be collected and added back to the training set. As this process repeats, Tesla's ML engineers can all go on vacation. ML code. Haha. 3 buckets of tooling landscape. Whew. There is a lot here. All in one. Versioning, labeling, data, training, evaluation, deployment. Software engineering. When it comes to writing deep learning, Python is the clear programming language of choice. Regardless of whether your colleagues write code in a lower level language, it is generally neat to join different components with a Python wrapper. Many different IDEs out there. Netflix based all of their machine learning workflows on Jupyter notebooks. Alexander Mueller's blog post outlines 5 reasons why notebooks suck. It is challenging to enable good code versioning because notebooks are big JSON files that cannot be merged automatically. Notebook IDE is primitive. They have no integration. It's very hard to structure code reasonably. You'll put your code into functions and develop tests while working in notebooks. You better develop Python scripts based on some test-driven development principles as soon as you want to reproduce some experiments. Notebooks have out-of-order execution artifacts, meaning you can easily destroy your current working space when jumping between cells of notebooks, yes. Recently, a new framework called Streamlit was introduced. Create machine learning engineers to create apps. Streamlit is building features that enable sharing machine learning projects as easy as pushing a web app to Heroku. We recommend using Conda to set up your Python and CUDA environments and pip tools to separate mutually compatible versions for our lab. Compute hardware. Google already released a switch transformer with orders of magnitude larger in number of parameters. This is amazing. This is a good resource. Shivans, I think you might be right. Some academics use MATLAB. I personally don't know much MATLAB. There is a new NVIDIA architecture every year. Kepler, Pascal, Turing, Ampere. We're up to Ampere. The more data you can fit on the GPU, the larger your batches are, the faster your training goes. For deep learning, you use 32-bit precision. In fact, starting with the Volcker architecture, NVIDIA developed TensorFlow's that is specifically for deep learning. Hey, there we go. Oh, cost. Here are our recommendations. If you're a hobbyist, build your own machine. Startups, build a sizable Lambda Labs machine for every ML scientist during development. Buy more shared server machines or use cloud instances during training. How much is a Lambda machine these days? I want to reach out to Lambda and see if they want to sponsor me. Lambda Deep Learning PC. That wind is not too loud on the microphone, is it? Oh, Ashik. Unlucky, brother. Your power went off. If you're listening to this, the wind isn't going through this microphone too much, is it? Workstations. How much is one of these bad boys? Customize your computer. I want two 3090s. So I could easily spend how do I spend 10 grand on a computer? Two 3090s, there we go. It's gonna cost me 11 grand. Oh, is this finished yet? That stopped at 96%. Why is that? Okay, we're on. Startups, buy a sizable... See, this is what I'm going to have to do. After my course is finished, I'm going to be working on a startup. So I don't have to buy that. I'm going to use what I already have, and then I'll scale up when needed. But let's come back to that. So this should work end to end. Thank you, Shaking Basket. I'm glad the wind is not too loud because the breeze is coming through and it's a great breeze at the moment. I want to keep it that way. Yeah, that's in US dollars. What's that? 11,800 US dollars equals 15,000 Australian dollars. 15,000 Australian dollars for a beefy Lambda churros that's working. Now, this is all we're doing is just going back through the code and just making sure it runs end to end with everything that we've done and seeing what we need to change. We did this before, but I want to make sure it runs end to end. So now this is going to train for a bit. We'll make sure this loads. Shaking Basket, hire me for the startup. I'm not looking to hire anyone at the moment. I need to start it first. But you'll see progress. I'm probably going to live stream it. So you'll see if it actually works or not. If it works, I might be looking into hiring people. Okay, that's training. That's good. Every cell has run as we want. I need to pee again because I've had so much to drink. And I'm going to get another drink. No, I don't need to drink anymore. I'm good. So this is running beautifully. Let's go back to here. Resource management. Docker Kubernetes. Oh, what's Grid AI? And Anyscale. Grid AI creators of PyTorch Lightning. Their vision is around allowing you to seamlessly go from training models of your computer to running lots of training jobs in the cloud with a simple set of SDK commands. Beautiful. Good for development. So TensorFlow is still the best for production. PyTorch Lightning looks like it's the fastest for development. Using TensorFlow Keras or PyTorch is the current recommended way to build deep learning models, unless you have a powerful reason not to. So PyTorch has academic projects. New projects like JAX and Hugging Face offer different or simpler abstractions. JAX focuses on a fast numerical computation with autodiff and GPUs across machine learning use cases. Grid AI. From the makers of PyTorch Lightning. Seamlessly train hundreds of machine learning models on the cloud from your laptop. Oh, I'm going to join the waitlist. Far out. Just let me put my email in. Easy install. Focus on machine learning. Let Grid handle the engineering. Built for Lightning users. Train instantly on CPUs, GPUs, or TPUs in cloud. Yes, this is what's up. Built by Lightning for Lightning. Join the waitlist. I'm going to look at this later. Lightning, PyTorch Lightning. This is cool. Okay, that works. All right, we're getting stuck. Where were we at? What do we have to do? Make sure the code really runs end to end. So this is what I'm doing. I'm running the code end to end. So making sure that the notebook I've uploaded to the course GitHub works. And then tomorrow I'm going to go through, because once the code works, I can then go back through it and explain what the code actually does. Probably a Sheik on Fast AI copying, or PyTorch Lightning copying Fast AI. Fast AI is made very well. Jeremy is an absolute beast. Actually, Jeremy Howard just moved to my home city. How exciting is that? So I wouldn't be surprised. I mean, Fast AI has been open source from the get-go, so if PyTorch Lightning copied stuff from there. Mixed float, yes. What's the talk? Hey, Christian Leone. What's going on, my friend? Welcome to the stream. We are writing some TensorFlow code, making sure that notebook I've just created for educational purposes works end to end. Do you know where that talk is, Ashik? PyTorch Lightning copied it. Well, this is the thing with frameworks, right? It's like there's so many out there now. I'm more of a just use one thing. What do you need to do? What's the startup going to be about? Well, we're going to leave that. We'll leave that to when I actually do it, rather than me just talk about it. We'll get the model from, this should work. So Sheik, Twitch's mobile phone app works pretty good, does it? The live stream comes across okay? So our loaded Google storage model performs pretty well. Hey, first time here, welcome. Christian Leone, new to ML. Oh, well, it's a fun place. There's lots to learn, I'm still learning. Ah, I see. So PyTorch Lightning is basically the same wrapper as Fast AI. Because Fast AI's learner is just absolutely phenomenal, isn't it? So I can delete these. Should be able to run this. And we're going to run this. So this should be very similar to what we got before. About 305 seconds for the first epoch. Really? I didn't even see that. Jeremy. What's Jeremy saying? These blinds are going crazy. PyTorch for AMD GPUs. That's dope. Okay, I'm getting distracted by Twitter again. I got heaps going on. TensorFlow, Fast AI, and learn software engineering, but it feels too much when you change focus. You're right. So that's why I've only tried to do one thing for like the past 6 months, and that's TensorFlow. Wow, the PyTorch Lightning founder publicly used baseless patent threats to try stop new competitors from creating open source software. Aggressive patent use like this means whatever. Lightning users could be up for patent fees if Lightning is ever released. Be careful. Maybe Determined should come up with its own API instead of copying Lightning's. Not a nice move for the open source spirit. Also pretty sure it's a violation of our patent and 100% copyright infringement. Hi William, we have absolutely not copied any of Lightning's APIs. In fact, our PyTorch API makes some significantly different design choices than Lightning does. E.g., we require users to step optimizers and run the backwards pass explicitly, which is a bit lower level but allows more flexibility when using the API. Wow. Yeah, the PyTorch CEO, PyTorch Lightning CEO dude doesn't look like a good person anyway. Jesus Christ. Gotta love a little bit of
Actually, before.
Jesus, why is it playing so loud? Alright, Twitter is getting me distracted. The simple thing about this is think about what technology you're building. I echo what George Hotz says about this. George Hotz blog. Here we go. GeoHot. I also have a poorly written blog. Oh yes, the AI control problem. This is a new blog post. I'm going to save that. But read this. Technology without industry. Is this what you're building? So here we go. Stop building shitty technology. If it centralizes power, it's bad. If it decentralizes power, it's good. Build technology that is inextricable from its narrative. Build technology that will give us freedom, not enslavement. One axis to consider. Does this centralize or decentralize power? The power itself is unstoppable. How we divide it is a choice. Whoa, that is... So, fuck Twitter. I get too distracted on that shit. Just build stuff that decentralizes power. Fast AI decentralizes power. Fast AI opened the world of the magic of deep learning to everyone. And if PyTorch Lightning and all these other people are coming along and trying to create patterns and whatnot around this sort of junk, I mean, this is why one of the reasons why I haven't kind of got into PyTorch is because if you go right back up to the chain where it originated from, Facebook basically do everything in the book. I mean, Google's TensorFlow is not really that, Google aren't really that much better, but if you want to compare two lesser evils, I would say Google are less evil than Facebook. Who knows? But it doesn't surprise me if the creator of PyTorch Lightning has just gone through and ruthlessly copied everything from Fast AI, because that's what Facebook do. He started, where did he do his PhD? Look at this. PyTorch Lightning, watch this. PyTorch Lightning. This is why I don't like to work at any company. I like to work on my own shit, because then I'm not tied to anyone. PyTorch Lightning. There we go. Team. This is why I have to make my own money. There we go. Where was that? Was it at Facebook? Previously at CLI VR Lab. Let's go here. Is this run by Facebook? About. Jan LeCun, there we go. Jan is amazing. All these people are amazing, right? I'm just saying. Yeah, VP and Chief AI Scientist, Facebook. This is the type of blog you want too for if you're a nerd. Mine's too fancy, right? So Facebook ran this group, and that's where this guy's from. So who knows? Did that copying mentality come straight from Facebook? I don't know. But if you're doing shit that is trying to centralize power, this is open source software, right? If you're trying to, why are you trying to pattern open source software? I don't know. I don't know enough about it. But this is a great blog post. This is what I think about when I try to build technology. Is the stuff that I'm doing creating more outsiders or more insiders. So the things I want to work on, I would make all of my stuff free if I could. However, I am part of the system that requires me to have some sort of fundage to do the things that I want. And so, not surprised, PyTorch Lightning copying FastAI. FastAI is a technology that gives freedom, allows people who don't know much about deep learning and AI to start getting in to the latest and greatest stuff. So anyone who hinders that, I'm not a fan of. But let's go. This is George Hotz. So George Hotz also streams on Twitch. This is partly another reason why I'm streaming on Twitch is because I like his Twitch stream. Geo Hotz. Is it Geo Hot? George Hotz. Here we go. George Hotz, go follow him. Yeah, great book there, Alex. Shit, how did this get moved? How the fuck did that happen? Am I allowed to swear on Twitch streams? Can you swear on Twitch? According to Twitch guidelines, you're allowed to swear while you broadcast. Okay. The AI control problem. Here we go. Put it out of your mind that the AI control problem is a mathematical problem with a mathematical solution. This is rationalist hogwash from the same people who, when pressed, don't really tell you polyamory is the rational choice, but do subtly believe that if you don't agree about polyamory, you are somehow less rational. Or perhaps just less rational, but either way, it isn't obviously correct, and can't you see it? Rationality is a wonderful tool, but it is only a tool. It can only deal in is not in ought. Well, I don't fully follow the internet drama. My understanding is that the neo-reactionaries were a spin-off of the rationaries, with Yaren and... What is this? I'm going to read this later. Here we go. This might actually finish on this epoch. See, and you also got to look at motives with this, right? Okay, here's another thing. So back on that topic, FastAI. How does FastAI make money? How? This is where you got to be very careful of what people's intentions are. So look back to what their income source is. FastAI, how do they make money? What do they sell? What do they sell? Nothing. PyTorch Lightning, we come into here, you realize, oh, these people just founded a startup called, look at this, also, very fancy website, FastAI, text. Only text. This is how you can tell as well. If a place has a text-based website, they're usually putting out real good stuff. Very fancy website, they got to fool you with the colors and try to get you in with all that sort of stuff. I'm not saying that PyTorch Lightning is not great. The product could be great. I'm saying just beware when it's a very fancy website offering you things with colorful stuff. Learn more about Grid. This is where PyTorch Lightning is heading, to selling you the services of Grid. I may look into Grid and see if that benefits me. I have no qualms paying for a product that benefits me. However, that's what you've got to realize. To get this thing off the ground, they may need investment. To do so, they may need to say, hey, we've done some really cool stuff with our library, some proprietary stuff. Even though FastAI might have already done this, if an investor was going, why should we invest in you to power Grid AI? They might say, well, our Lightning, we're the only people to have done this, to have implemented this, when the feature actually came from FastAI. Whereas FastAI's motive, completely funded. I'm pretty sure Jeremy funds the whole thing himself. So, yeah, that's what you got to be wary of. What are people's motives with what they're creating? So this shouldn't take too long, another 4 minutes for the epoch. What were we looking at before? That was cool. Yeah, building a deep learning PC. So this, don't mind. I like this because I can buy this product if I wanted to buy it. But when you have to sign up to wait lists and all that other bullshit, not a fan. I just want to buy what you are selling. If someone is selling something, let me buy it. Don't ask me to talk to someone. So what would I actually need with a computer? This is exciting because this Colab instance is using a Tesla T4. I have a deep learning PC downstairs with a Titan RTX. I'm going to really push that thing to its limits. I haven't pushed it to its limits yet, so I definitely don't need something like this. But if I do need something like this is probably where I'm going to go. Lambda. What are they posted on their blog too? Blog. Install TensorFlow and PyTorch for RTX 3090. Oh, benchmarks between A100 and V100. I want to start a Jekyll blog and just write text-based posts. Look at this. I also hate these chat windows. Is there an extension where I can get rid of these chat windows? A100 versus V100. If you're joining into the stream and all you're seeing is me ranting, and you don't want to see that, well, no, I'm not going to apologize, but I have been on a little bit of a rant lately, but what else are you going to do while your model is training? We could have sit around and done some push-ups. That's what we could have done. You know what? I'm going to do some push-ups. 20 push-ups. Everyone, if you're watching this stream, 20 star jumps, 20 push-ups. We need to break it up. We've been sitting down for too long. Start off with the star jumps. Boom. Now, 20 push-ups. We have a minute to do them. You have a minute 25 to do 20 push-ups. I'm going to do them straight because I can do 20 push-ups, but you might do 5, 5, 5, 5. Add it up, that's 20. Easy money. On what live streams are you going to be able to do live TensorFlow coding as well as getting jacked? What's the number one rule of coding Python? If you're writing Python, you've got to be rocking Pythons. That's why I am the internet's most shredded machine learning engineer. You know that's a joke, right? But I probably am. With a mohawk. That's the kicker. Okay. Wow, okay, so it's about 2 times faster on many things. Around about 2 times faster. Okay, boom, we've trained. So this is very good. Our notebook is running end to end without any qualms so far. Save it before evaluating. Tick. Well, it is. I did actually ask for a mohawk, but it kind of, after a couple of weeks, it turns into a bit of a mullet. But it was originally a mohawk. See, a mullet I feel like is thicker, whereas this kind of comes into a point. But I did ask for a mohawk. It just ends up being a mullet after a couple of weeks before I get it recut. Okay, we're going to let this run. Now we do some squat jumps. We do 30 seconds of squat jumps. These are called explodes. What, the time's going up? 30 seconds left. The time is going in between 30 seconds. That's okay. Been sitting down for too long. We've been on this stream for almost 3.5 hours. Oh no, 4 hours, nearly 4 hours. Oh, starting to feel the burn in the legs now. I've got jiu-jitsu training tonight. I'm very excited. 3 seconds. Oh. 79% accuracy. Beating the deep food paper. Whew. That could be a rule from now on. Every time a model's training, we dance around. Language, holy crap. 8 GPUs. Getting distracted again by other shit. Let's make sure the loaded model works. This should all run end to end. I haven't changed a single thing. These warnings don't work. Oh, what did I just delete? Edit. This could be the last one. If we pass this, the model should work. The notebook should work. Yes, a chic, that is such a great idea. In the actual course, I'm going to do that. For when a notebook takes a longer time to run, you have to do some push-ups, some star jumps, or some squat jumps. Okay, I believe that's it. That's what we wanted to do in this stream, is to make sure the code really runs end to end, upload trained models to GS, make sure mix. So we've done actually a fair bit. Upload trained models to GS so a student can download the trained versions and use it. Make sure mixed precision works with the save and load model. Tick, tick. Next is to, let's do these tomorrow probably. Clean up data loading. So now all the code works. We actually have to do probably, if today we didn't write much code, tomorrow we'll probably write even less code because we need to fill in, see here, all of the TKs. So there's basically one for every section. We need to fill in where we need text explanations for what's happening. So there's heaps of code in this notebook, but we need to kind of explain what the code is doing a bit better than what we are, just like all the other notebooks. But let's save a copy of this in GitHub. If you're watching this and you want to help me out, you can try to run this. So update and remove useless cells. Code should now run end to end. You can give this a shot, load it up, run it end to end, try your own stuff on it, but now it should definitely work because we just restarted our runtime and basically ran that whole thing together. But I believe that'll be the end of the stream. So thank you so much for everyone who tuned in. By the way, if you haven't seen the whole stream, you can go to this YouTube channel. So I'll show you. See past live streams here. I'm uploading all of these in full to another channel called Daniel Burke Archive. So if you want to see them, like these streams, if you can't make the live on Twitch, go to this YouTube channel, Daniel Burke Archive. Archive is spelt like archive, archive.org. And you'll be able to see all of the past streams. They're completely unedited, so they're just as if you're watching them live, so you can play them in the background while you're coding or something like that. Listen to me rage at technology companies copying other technology companies. But that's the nature of competition, right? But I think that's the end of the stream. Thank you all so much for tuning in. Have a great day wherever you are, whether it's afternoon. I was about to say afternoon, but that's only for me. Keep machine learning, keep moving. Remember, if your model's training, push-ups, squat jumps, star jumps. I'll see you guys next time. Thank you for your help. Thank you, Ashik, for your help. Thank you, Shaking Basket, for your help, and everyone else who joined in. Peace out, team.